Hello, everybody. It is Wednesday and Thursday, the 9th and 10th of February. What I did here is you're actually seeing a split screen. On the left side, you are seeing our slides and you're seeing your digital notebook. And I'm doing that for a reason today. So the first thing we're going to do is we're going to pop into Schoology. And again, recordings are always here under the orange folder. And I'm going to be moving these last few that go into force and motion so that we're just seeing this. Our materials, our unnarrated slides are here. And the recording will be right below this, 29-10 will be right here. So you can do this. I just opened two windows and I have a left and a right side. You can always do that. So if you need to, that's especially helpful when we talk to you about things like videos or that are embedded. So what season is in the Southern Hemisphere? So first thing I'm going to do is I'm going to come over here. I'm going to go to the Do Now for today. And it says, what season is it at position B in the Southern Hemisphere? Below. So B. And so you got to look at this and figure out, well, wait a minute, Southern Hemisphere, I want what's on the south. So if it is winter in A, and I come over here and then spring is here in our hemisphere, the northern, since it's the opposite, it would be the fall. What are the three different types of plate boundaries? Divergent, convergent, and transform? Absolutely. And you can draw a picture. People asked, how do I draw a picture? And I said, really, it's kind of easy. You click on the comment box, and there's a little box here that says insert comments. You can click on, it's hard to see right here, symbols. And there's arrows here, and you could actually put these right by your each one of the words. And then what you could do is answer the last question, which is, what's an example of a land feature? So for divergent, we might have rift valleys. For convergent, we might have mountains or subduction zones where we have the deep ocean trenches. And then for our transform, faults or earthquakes. So what we're doing today is we're going to demonstrate your knowledge of plate tectonics and the land feature found at different plate boundaries. I will define key vocabulary and interpret topographic maps. So we have two things today. So we're going to define, describe, transform convergent boundaries, identify the features, and then we get into topographic maps. We're going to talk about elevations, contour lines, and intervals. And we're going to interpret topographic maps, define elevation, find hills and valleys and rivers, depressions, plateaus, look at steep slopes versus gradual. Seems like a lot, but I think we got it. So now I'm going to flip on my right side. I'm going to flip to my digital notebook because we're going to do this first. Oops, sorry. We're going to go back to Schoology. My bad. So we're going to go back to the materials. We're going to go back here to where it says materials on the left side. And right here, I'm going to go, it says you're going to go here into Unit 6 assignment, and you're going to do the plate tectonics quiz with audio. So you do that one there. And then you're going to, on slide 3 of your digital notebook, so that's why I had my digital notebook open, you're going to graph your quiz here in the first column and the third. This quiz covers 8.9A and 8.9B, okay? And then when you're done, you can work on assignments. Now, if you were here in class, we would then immediately after this flip to the next slide. So our next slide is topographic maps. So I'm going to shift down here. And we're going to look at topographic maps. In the slide presentation that is not narrated, you want to click on this, and there's a great video from REI that helps you explain these three. What is a topographic map? Well, it's a two-dimensional drawing of a landform. What is elevation? It is the height. And what is a contour line? It is a series of dots that are connected that are all at the same elevation. Again, the video is really great. And this is what it might look like. So this is how you would picture it. And this is the topo map, the flattened version. And then right here, we're going to talk about contour lines. Your slide is actually a little bit better, and it explains how to do it. So you would fill in the blank there. Slide 17 is a drag and drop where you're going to drag the descriptions and match. So what is a topographic map? And who would use it? Well, who would use it is hikers and military people. And then let me grab this other one. Grab that over. Oh, sorry. Grab that other one. Bring this one over just a little. And that is a map. Oh, I see why it doesn't want to go. Okay. Bring it over a little bit here. Oh, undo. I'm going to bring it over here. Bring that little box here. There's a topographic map. What is a contour line? After watching that video, you should be able to answer that question. So this shouldn't be too difficult for you to work through. And what is an interval? It's a line. See, the distance between, between contour maps. Remove our little friend over here. And it is a line joining points of equal elevation. So there you go. We're going to do these together. We're going to do slides 21 and 22 together. This one, let's practice. What's the interval? Well, that's the distance between just two lines. But let's come back to that because we can use that formula here on slide 16. So what's the elevation between the two contour index lines? These thicker lines are contour index lines. So I take the larger number, 800, I subtract the smaller one, 700, and I would fill in 100 because I would have, let me do it this way, 800 minus 700 equals 100. Okay, and then I would take that number, that 100, and I would divide by 5 because there's 5 lines, and that would equal, 20. Good job. So what's if I know that the space between each lines is that, what's the elevation of point A? Well, that would be 720. What's the elevation at B? Well, it's still one higher, so it'd be 820. There we go. Okay, same here. You're going to do these together. You want to pause and do this. So what's the elevation here? There's 40. Beaker Hill, 50. Who's higher? Of course, Baker Hill. Oop. Baker Hill. And what is the contour interval? Well, from line to line, it is 10. I really like this second slide here, 20, because it kind of shows you how they take this flat map and they build a 3D map. And this is like a slice. So this is kind of, look, and it says, this is a graph that shows what the mountain or hill looks like from a side view. And then notice the contour lines and the gentle slope. So we're working through the slides. So on this slide here, we want to look at this and we want to say, well, what's here? Well, a V-shaped contour line indicates a river valley, and that starts here and goes down. Kind of think about it as if you dumped over a bottle of water. The bottle of water doesn't necessarily shoot out in a straight line and stay in a straight line. It kind of creates a V-like. So that's a river valley. And the V always points upstream to the water source, toward the water. Okay? So we have this little area over here that's kind of sunken right there. Okay? We call that, that is a, what? Oh, yep, a depression, because it's sunk. Something that falls in, a little depression. And the little lines that are inside of it that make you think that are the Hatcher lines. And here's the interesting thing. There is not enough change in elevation to have another contour line. So that's why we have the little Hatcher line. And this is likely been made from something called a crater. Okay. Now we talk about how steep or how slope a hill is. The closer the lines are together, the steeper the slope. So we're going to drag that word here. We're going to drag the gentler here. Okay, the farther they are, the easier and smoother it is. So, so our last word goes right there. All right. So just to kind of give you a little example, and so that's all we did today. You can do slides 22 and 23 on your own in your notebook. I'm going to close out that set of windows. I'm going to open this one up just a little bigger here. And I really wanted you guys to see this. This is a really cool map of Yosemite National Park. And every one of these is a line. Even where it looks really dark and thick and black, if we were to be able to blow this up, those are a whole bunch of lines all together. And right here is a very famous geographic or geologic feature here called Half Dome. This is what it looks like. Look how steep this side is. So right here, do you see how steep those lines are and how close together they are? That's because That's showing here, and then the bubble out is in the back here. So right there. So that's just to give you an example. And here's our exit ticket. Which side of the mountain has a steeper slope, the east side or the west side? So we're going to use our compass rose and say, okay, north, east, southwest. Okay, steeper, lines closer together. My east side. If I walked from A to B, are you going uphill or downhill? Look, the numbers are getting bigger, so we're walking, you got it, uphill. And then lastly, what is the contour interval? Well, here we go. Let's see, that's 400. So 1, 2, 3, 4, 5. Oh, that's maybe not. That's 200. So 50, 100, 50. Oh, that might work. You're going to have to figure that out. So good luck with that. And I hope you guys have a great afternoon. And that you enjoyed this, and we will see you all tomorrow.